Next theorem, the radical axis of any two circle is perpendicular to the line joining the centers. So let x square plus y square plus 2gx plus 2fy plus c equal to 0. That is equation number 1. That is the first circle. The second circle is x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0. Right? Be the given two non-concentric circles. Let C1, C2 be the center of 1 and 2, and R1, R2 be the radius of 1 and 2. So C1 equal to minus G minus F from the formula. Right? C2 is equal to minus G1 minus F1. See, since 1 and 2 are non-concentric, definitely for center of the both circle not equal. That is minus G minus F not equal to minus G1 minus F1. Let P1 be the radical axis of 1 and 2. Right? So first circle, this is the second circle, P is the point. So common tangents PA, PB. So the locus moving point P, right? The path of P is radical axis, right? P dash. Join C1 and C2. Join the centers. So aim is P dash is perpendicular to C1, C2. We know that the equation of the radical axis P dash with respect to 1 and 2 is 2 into G minus G1 into X plus 2 into F minus F1 into Y plus C minus C1. So slope of the radical axis P dash is, let it be M1, that is equal to minus 2 G minus G1 by 2 into F minus F1. We know Ax plus By plus C equal to 0 slope is minus A by B, right? So coefficient of X by coefficient of Y, minus of coefficient of X by coefficient of Y. So you will get M1 equal to minus G minus G1 by F minus F1. That is equation number 3. Right? The slope of the line joining the centers C1, C2. Right? We are using 2-point form of the slope. So if there are x1, y1, x2, y2 are 2 points, then slope of that line joining x1, y1 and x2, y2 is y2 minus y1 by x2 minus x1. Right? Here we are going to use C1 and C2. Right? C1 minus G minus F, x1, y1. Minus G1 minus F1 is x2, y2. Right? So F1 minus F1 minus F minus G1 minus G. That is equal to M2, let it be M2, M2 is equal to F minus F1 by G minus G1. That is equation number 4. Right? So from 3 and 4, M1 into M2, multiplying both slopes. So you will get minus G minus G1 by F minus F1 into F minus F1 by G minus G1. So you will get minus 1. So product of two line slope, product of the slope of the two lines is equal to minus 1, then both lines are mutually perpendicular, right? So P dash is perpendicular to C1, C2. Hence the radical axis of any two circle is perpendicular to the line joining their centers. Next result, the centers of any three circles of non-collinear, then the radical axis of each pair of the circle chosen from these three circles are concurrent. That means there are three circles, but they are non-collinear centers, they are not in same line, right? Then you can take first and second circle radical axis, second and third radical axis, third and first radical axis. That is why radical axis of each pairs of the circle chosen from these three circles are concurrent. They passes through a single point, that is their point of intersection of the radical axis is only one, right? Let the given circle three circles be x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0. First circle x square plus y square plus 2g2x plus 2f2y plus c2 equal to 0. Second circle, and x square plus y square plus 2g3x plus 2f3y plus c3 equal to 0. Third circle. So first circle, second circle, third circle. Right? Let P1 P1 dash, P2 P2 dash and P3 P3 dash be the radical axis of the pairs of the circle 1 and 2, 2 and 3 and 3 and 1 respectively. So this is P1 P1 dash, this is P2 P2 dash, this one is P3 P3 dash. Our aim is lines P1 P1 dash, P2 P2 dash and P3 P3 dash are concurrent, passes through, their point of intersection is only one point, right? To prove P1 P1 dash, P2 P2 dash and P3 P3 dash are passes through a single point, the equation of the radical axis P1 P1 dash with respect to 1 and 2 is, we are going to use the radical axis formula. So from the formula we will get 2 g1 minus g2x plus 2 f1 minus f2y plus c1 c2 equal to 0, fourth one. So equation of the radical axis of P2 P2 dash with respect to 2 and 3, using the formula we will get 2 into g2 minus g3x plus 2 f2 minus f3y plus c2 minus c3, that is equation number 5. Next, the equation of the radical axis of P3 P3 dash with respect to 3 and 1 is, so 2 into g3 minus g1x plus 2 f3 minus f1y plus c3 minus c1, that is equation number 6. We know if the three lines a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0 and a3x plus b3y plus c3 equal to 0 are concurrent if and only if the determinant value, take the coefficients, right, a1 b1 c1 first equation, a2 b2 c2 second equation, a3 b3 c3 in the determinant value is 0, right? From 4 5 and 6 we are taking the coefficient of x, y and constant term, right? From the first equation 2 g1 minus g2, 2 f1 minus f2, c1 minus c2, first row of the determinant. Second row of the determinant 2 g2 minus g3, 2 f2 minus f3, c2 minus c3. Third row of the determinant 2 g3 minus g1, 2 f3 minus f1, c3 minus c1. We are going to prove this value is 0, right? So this is approximately equal to, you can cancel 2, first row, first column, second column you are having 2 2 2 common, right? You can remove that 2 from the property of determinant. So this is equal to approximately, this is exactly, this determinant can be written as g1 minus g2, f1 minus f2, c1 minus c2, g2 minus g3, f2 minus f3, c2 minus c3, g3 minus g1, f3 minus f1, c3 minus c1. Now keeping the first row as it is, g1 minus g2, f1 minus f2, c1 minus c2. Second row can be written as second row plus the first row, right? So g2 minus g3 plus first row, g1 minus g2, f2 minus f3 plus first row, f1 minus f2, c2 minus c3 plus first row, c1 minus c2. Keep the third row as it is, g3 minus g1, f3 minus f1, c3 minus c1. We are doing these operations, right? Now that is g1 minus g2, first row is f1 minus f2, c1 minus c2. Second row becomes g2 minus g2 get cancelled, so you will get g1 minus g3. Similarly f2 minus f2 get cancelled, f1 minus f3, c2 minus c2 get cancelled, c1 minus c3. That is the second row. Third row will be g3 minus g1, f3 minus f1, c3 minus c1. So first row as it is, g1 minus g2, f1 minus f2, c1 minus c2. Taking that minus outside from the each terms in the second row, or multiply with minus 1, whatever it is. So you will get multiply with minus 1 mean minus 1 into, right? So it will become g3 minus g1. Otherwise you take minus, then you can cancel those minus, right? So better you can multiply with minus 1, you will get g3 minus g1. Second row becomes f3 minus f1, c3 minus c1. Third row as it is, g3 minus g1, f3 minus f1, c3 minus c1. But I just taken minus from the outside, that is why I need one more step. So better you can multiply the second row with minus 1, then you will get immediately the last step. So row 2 and row 3 are equal, therefore from the properties of determinant value equal to 0, right? Therefore the radical axes are concurrent. Thanks.